Alright, similar figures in scale drawings. Indirect measurement is when we find unknown distances through proportions. And this is different from direct measurement. The in there, of course, means not, so this means not directly. That means you're not measuring it, with the measuring tape or actually going up to it. You're doing it through proportions. So let's talk about how to set up those proportions. Alright, let's say the sun is shining and you know how tall you are, and you also know how long your shadow is. So let's say your shadow is 7 feet, and we measure you, and believe it or not, this kid right here is 6 feet tall, and we can find out how tall Bigfoot is. All we have to do is measure Bigfoot's shadow. So let's say we measure Bigfoot's shadow, and no, this isn't drawn to scale, and Bigfoot's shadow measures 16 feet. And the question is, how tall is Bigfoot? And that's from the bottom all the way to the top of his head. So we set up a proportion here, and that proportion can be height over shadow. So we can write height down over shadow. Always write the words down. This helps you keep track of what goes where. So if I write the height on the top and the shadow on the bottom, it has to be that way for both of these individuals. So the height of this kid over here is 6 feet, and the shadow of this kid is 7 feet. And we're going to set that equal to Bigfoot over here. So this again represents the kid, and the next one is Bigfoot. Get in the habit of labeling everything, because if you label it, it's easy to keep track of and you can just plug stuff in. So for Bigfoot, his height we don't know, so we are going to call that X. But we do know his shadow. His shadow measures 16 feet. And there's his shadow. So 16 feet. And now 7 will not go evenly into 16, so we need to do cross products. So cross multiply. 7 times x is 7x. 6 times 16 is 60 plus 36, 96. And then I divide by 7. If you can't do that in your head, just do it off to the side. 96 divided by 7. Go once. And we'll go 3 times. And we get 5 left over. So that would be 13 and 5/7 is x. So 13 and 5/7 feet. So Bigfoot's over 13 and a half feet tall, 13 and a half foot tall, as you might have guessed. Now keep in mind though, this only works if it's the same time of day. So if we measured this kid at 8 a.m. and then measured Bigfoot when the sun had moved in the sky closer to noon, Bigfoot's not going to have a shadow, so we're really not going to have a comparison. So they have to be measured at the same time of day, in the same place. Alright, let's talk about maps and scales. If we wanted to find out how far it is from Wilmington to Cary, and all we had was a map to go by, well, first off, let's look at where Wilmington is. Wilmington's right here, and then Raleigh is right here. Actually, this says to Cary. There, I changed that back to Raleigh. So if we're going from Wilmington to Raleigh, and Cary was just a little bit west, it looks like. If Raleigh is, we need to figure out how many centimeters that is. So we would actually get out our centimeter ruler, and we would measure it, and see how far is it from there to there. And let's say that that measurement gave us 43.7 centimeters. I know it's not drawn to scale. But now we can set up a proportion given what we just measured, and I'm going to label it as, let's say, the map and the actual. Because the map is just a scaled down version of the actual. So on the map, and let's say I'm talking about, the map is in centimeters, and actually it's given in miles. So we want to write a proportion based on that information. So I'm going to start by writing my scale down. My scale is down here. It's 1 centimeters is 3 miles. And centimeters goes on top, so it's 1/3. And now I just need to place what I've actually measured. I measured this distance and got 43.7. Ah, don't be critical again. I know they don't say the same thing. And I got 43.7. That goes on the top. And then we don't know how far it really is. Maybe we do, but we don't know based on the given information how far it is. So that's going to be our X on the bottom. And just make sure you're putting this stuff in the right spot. So centimeters go on top, miles go on the bottom, and our actual map measurements are on the top, and our real distances are on the bottom. So now I'm looking at this, and I could just do one will go into 43.7 times and do equivalent fractions, or I could just cross multiply. So if I cross multiply, I get x times 1 is x. 3 times 43.7, I'll do that off to the side. 3 times 7 is 21. 3 times 3 is 9, plus the 2 is 11. And then I get 12 plus the 1 is 13. I have one number behind the decimal, so I need to have one number behind the decimal there. So I get 131.1 miles. And that's the actual distance from Wilmington to Cary. Actually, to Raleigh. Cary is pretty close to that. So start driving. Be there in a couple hours. All right, now let's talk about similar figures. Similar, and that's our mark that we use for similar. It's a little squiggly line. Figures have corresponding, this is our symbol for angles. So you can see it's like the measurement from a protractor. Angles and sides. And some things that we know, if two figures are similar, that actually tells us quite a bit about those figures. And the first thing it's going to tell us is that the angles are congruent. And congruent is just an equal sign and then a squiggly on top of it. And we're going to write that word down, congruent. And congruent just means equal or the same. So the angles are going to be the same. The corresponding angles are congruent. But the sides are not going to be the same because one's bigger and one's smaller. So the sides are going to be similar. And remember, similar is just the one squiggly line. And that means similar or proportional, which means we can solve for it. Remember how a proportion works? If you have 3 bits of information, you can find the 4th bit. So if we know 3 of the sides, we can set them up in a proportion to find the 4th side. So let's do an example with that. Let's go ahead and draw an obtuse triangle with me. And we'll call this W, X, Y. I know, real creative, right? Alright, well maybe I'll make the next one a little more creative. And then we'll fill in the angles. We have a 30-degree angle here. I write that on the inside since it's the measurement of this little angle right here. And then this is 6. This is 4. Let's say that's all we know. But then I have another triangle that's similar to it. It's going to be a little bigger though. And this one I'm going to call UNC. There, that's better. And let's say this triangle, I know the measurements are 12 right here. We don't know this one, so we'll call that one X. And let's say that we know this is 30 degrees. And here's what's given in this problem. We're going to say given, this actually tells you a lot, what I'm going to show you, given the triangle WXY is similar to the triangle UNC. And then we're told to find segment UC. And the reason I know that's a segment is because it has the line over top of the letters. So it's wanting us to find the distance from U to C. That's segment length. So I'm going to set up a proportion. So short over long is one way to say it. Another way to say it is you can look at the corresponding sides. I'll show you that in a second. So for short, let's look at the first triangle. That's the shorter side, that's the longer side. So I could say 4 to 6. And this is for my first triangle. So 4 over 6. And then in my second triangle, the shorter side is the X, the longer side is the 12. So I could say X over 12. And that, again, that was my second triangle. So I'm just being organized with how I write this. The short sides are written on top, the long sides are written on the bottom. And the first ratio is my first triangle over here. The second ratio is my second triangle over here. Now this is pretty easy to solve because 6 goes evenly into 12 2 times. So I can just multiply by 2, and I know 4 times 2 gives me 8 for X. But the other way you can look at it is WY is my 4, and check this out. W and Y are the first and third letters, so that corresponds to my first and third letters over there. So that's why they're both written on top. These two are corresponding. And then look at the 6 and the 12. The 6 is WX, the 12 is UN. WX is my first two letters, UN is my second two letters. So those are both corresponding to each other. Alright, let's do one more example with similar figures. Alright, let's say if parallelogram PQRS is similar to parallelogram TUVW, the following must be true. In other words, we don't even need a picture or a diagram to know what's true because we know about similar figures. We know about the angles. Angle P must be congruent or the same as one of the angles on over here. So look at your first letter, P. Look at your first letter over here, T. So the order matters. So angle T. And what else do I know? Angle Q must be congruent to Which one corresponds to angle Q? That's the second letter. What's my second letter over here? The U. So I'd say angle U. Let's keep going with that. Angle R must be congruent to, that's my third letter, so my third letter here is V, so angle V. And then angle S and angle W are both my fourth letters, so they must be congruent. And I'm just going to make a note so I remember P corresponds with T. That means they go together. They're similar to each other. So the positioning very much matters. And likewise, Q goes with U, R goes with V, and S goes with W. Alright, now let's talk about the sides. So for the sides, it works the same exact way, except now we have two letters represented by a segment. So for instance, PQ, that's my first and my second, correspond to TU. And I write the sides with a line over top of them. That means segment PQ is similar to segment TU. And I also know that my QR, my second and third, are corresponding to the UV. So I would say segment QR is similar to segment UV. And these were all the angles. And now I'm doing all the sides. So now let's do RS. RS goes with VW, the Volkswagen. Oh wait, maybe I should write that the other way, huh? There we go. And now our last one is a little trickier. You just take the first and the last letters. And this is easier if you draw the figure, like P, Q, R, S. If you actually draw it, you can see it better. We've already done PQ, we've done QR, we've done RS, we just haven't done PS. So you just take the first and the fourth letters, and that's easy to see if you just draw the diagram. So PS, my first and my fourth, goes with my, what's my first and my last here? TW. So those are corresponding. So how does that help us? Well, I'm just going to give you a little bit of information, and we're going to solve from there. Let's say if angle S equals 78 degrees, then we know angle W. Because look at S and W. We said earlier, S is congruent to W. That means if we know S, we know W. So that one's going to be 78 degrees. And let's do one more. Let's do something with the sides. So if we know PS is 5, PQ is 4, and let's say that TU is 6, then find TW. Alright, now these are the side lengths. So the side lengths aren't as easy as the angles. The angles, we just look for the corresponding one, they're the same. For the sides, we need to set up a proportion. So I'm going to write a note, use a proportion. And write the words down. The words are very important. And here I can just write, for instance, the side length. So I'm given PS. I'm just using what I'm given. PS is 5, so I'll fill that in. And that corresponds with, I'm sorry, we have PQ. and PQ is 4. So I'm just writing down what I was given. PS and PQ, they both represent the first triangle. And I'll set those equal to the second triangle, and I'm going to make sure I'm using the corresponding sides. So what corresponds with PS? Let's look at what I've written up here. PS goes with TW. So that means TW goes up there. And let's look for a second. What goes with PQ? Well, I'm going to look up here to what I've already written. PQ goes with TU. So TU gets written there. And now I just plug in what those are. I know that TU is 6, so I'll plug in a 6 on the bottom. I don't know TW, so that's my X. So I just cross multiply to solve, and I get 4x equals 30. Divide by 4, it's a one-step equation, and x is going to be, 4 will go into 30 7 times with 2 left over out of 4, so that's 7.5. So just keep in mind that we wrote the corresponding sides on the top. PS and TW are corresponding. PQ and TU are corresponding. And the first ratio was my first triangle. Or actually, that's not first triangle, that's the first parallelogram. So I should have made that shape different. The first parallelogram and the second parallelogram. So just be organized and write the corresponding on top and the corresponding on the bottom. Oh, and watch out for Bigfoot.